Team, welcome to ISTQB level certification foundation level for day 2, and I'm indeed happy to welcome you all. And we'll first go through today's agenda. Today's agenda, you all know, this is the first chapter, fundamentals of testing. In this, we have just covered this part. Why is testing necessary? Today, we will try and cover what is testing, the 7 principles of testing, and fundamental test process. In which we will just cover the first half of the fundamental test process, because we will not have time to complete it in just a matter of an hour. So we will also continue with fundamental test process in the later sessions. And as usual, we will have mock test at the end of the session. Alright team, let's get started. Today's topic is very easy, very interesting as well. Just if you are able to follow what we are speaking and what is your understanding with regards to the context that we are discussing, it is very easy to crack the test, as well as the class or unit test will help you to develop your understanding about the relevant areas that we are discussing in the sessions. Fine. If you have any questions during the session, please post it in the chat channel, and I will be able to address it during the breaks. In the sense, once we cover up one particular slot of the topics, then we will come back to the questions. Alright team, let's get started. First thing is, today we are going to talk about what is testing and what testing does. So we all know testing is an activity of finding the defects, uncover it, and then report it so that you can bring out as many defects as possible during the process and it can be get fixed. There is also a process called debugging. So debugging is a process that developers do. So this is the area where you can also expect questions. What is the difference between a debugging and testing? Testing is a tester's activity. Debugging is a developer's activity. By going through the piece of code and with regards to what the incident report, what is the defect says, they will be able to fix the defect by going through the process of debugging. They will execute the lines of code line by line to ensure that where the problem is actually occurring, and then they fix that particular issue in that piece of code. So what is testing then? It is nothing but a systematic exploration of a component or system. You are systematically testing it with the aim of finding and reporting defects. With the aim of finding and reporting defects. One most important thing that we need to understand, team, that is debugging, whatever the testing that you are doing, and then you are raising a defect, the changes and corrections are checked for their effect parts on the other parts of the component or system. What this means is that you will be doing regression as part of the changes that they have incorporated. So what is the testing that we are going to do? We also need to ensure during the testing process, we have to take corrective action. Corrective action is taken by the dev team, which we are checking against, and we are required to check the relevant areas to ensure that we are covering the regression testing as well. Fine. And debugging is something related to the developers. It's not to do with the testers. Okay. Fine. Now the next thing is, we have to talk about the static and dynamic testing. That's why I put it in a table so that it is very easy for us to grasp. First is static testing. What is static? Static is something that is constant, that will never change, in the sense you are not static, in the sense it's not going to change over a period of time. So static testing is the terminology used when you are actually executing, when you are not executing the piece of code. You are going to do a review, or maybe a code review, or a design review, or your architecture walkthroughs, or design specification walkthroughs. In the sense, you will not do the actual testing. You will not open the application. You will not open the application to execute that particular test case or test script. Here the idea is to ensure that The static testing is performed at the very beginning stages of your test life cycle. The first testing that one should be doing ideally is static testing. Walkthrough of the requirements, review, code review for developers, it would be code reviews and design reviews and architecture reviews, and also you will go through this specification documents if it has got any errors or not. Whereas dynamic testing is a actual testing that we are doing it by what you are doing by doing the dynamic testing, you are indeed executing that piece of code. For example, if I just go to google.com and I type my user ID and password, we are nothing but executing that piece of code that are written by the developers. So dynamic testing is the program under test with some data. So we speak of test execution in this context. So this is the real test execution. Dynamic testing is the real test execution. Whereas static testing is just a code walkthrough, reviews, or inspections. Inspection, code walkthrough, and reviews will be covered as part of static testing. Fine. Now testing itself is a process. It's not just one activity. It is a process wherein you set your objectives clear, you execute it end to end, and accordingly you will raise that incident or defect report, and based on the defects, dev team will take care of. So it's a process, test itself. So we need to define a test process so that we do not miss any critical step. So testing itself is a process, it's not just an activity. So that's what the crux about this particular area, nothing more than that. Okay, we will be designing our test cases, you will be designing your test data, all those things, and you will ensure that you do not miss any of those critical steps. So you have to follow the process that has been laid. It is different for different type of technology or whatever it is, but you will follow the best practices. Great. So in this, what is the recap? What is debugging? We have seen it is a developer's activity of executing the line of code, piece of code line by line to spot the defect. What is the testing? It's a tester's activity to ensure that we are able to find the defects. We are bringing out the defects. That is the context, and raise defects. Static testing versus dynamic testing. Again, we have seen that it is a code walkthroughs, inspection and reviews, whereas dynamic testing is the actual test. And what other elements apart from test execution are included in the testing? So this is one good question. What other elements apart from test execution are included in testing? Other elements such as test preparation, test planning, all those things are included as part of testing, because we talked about this as a process. We talked about this as a process and not just a testing is an activity. Fine. Now we are coming into little more critical areas. So far it's all pretty smooth. It's all very basic in nature. It's all fine. Very straightforward. From now on, we need to grasp what is required in this context, and also you need to apply your thought process into it to ensure that you are answering the questions correctly. It's not going to be cakewalk. Please focus on the session and also try to answer the questions at the end of the session. All right. General testing principles. So there are 7 general testing principles. First is principle. What it says is testing shows the presence of bugs. Testing shows the presence of bugs. Okay. All right. So now we are going to talk about general testing principles. The first thing, what it says is that testing shows the presence of defects. So the first principle, what it says, testing shows the presence of defects. So by doing the test, we are uncovering one or more defects. We are uncovering one or more defects. And other than that, there is also a controversial statement here. Testing cannot show that software is error-free. What this means is that if you are done with your testing, it doesn't mean that your software is 100% perfect. It's the process of finding one or more defects, that's fine. But at the end of the cycle test execution, we cannot claim that it is an error-free. And the main purpose is to find defects. There should be test should be designed to find as many defects as possible. So testing shows the presence of defect, but at the end of the cycle, we cannot claim that our software is perfect in all dimensions. Fine. This is a very simple principle. Next comes exhaustive testing is impossible. Since yesterday we have been talking about risk, prioritizing our test, it's on the same lines. Exhaustive testing means an approach which is taken to test all possible combinations of data, all possible combinations or all the branches of your code, all the path of your code. It's exhaustively you are testing the software. What the principle states is that exhaustive testing is impossible. It is not at all possible because we are talking about some critical or complex applications which might take ages for you to test even if you wish to test. So application under test has extremely simple logical structure and limited output. It is not possible to test for all combinations of data. For this, what we need to do, we need to prioritize and assess risk accordingly so that we concentrate on the most important or critical aspects of the application. Great. Again, this is a very simple principle. Let's move on to the next principle. What it states is that early testing. Early testing, we should start the testing earlier in the cycle, in the sense right from planning phase. Right from planning phase, we need to start our testing parallel. We should not be testing after we receive the build. That is the point here. So earlier testing activity is started, the longer the elapsed time is available. Elapsed time in the sense the time between your defect and raising the defect and fixing it. Okay, we do not wait until the software is available for test. So this is the thumb rule. Early testing, we should start early testing and it should be right in the beginning of the software life cycle. Okay, and use of reviews. So what it means that error, defect and failure cycle, whatever the cycle, that can be brought very earlier because you are starting your testing early. So in this early testing, we are trying to find defects and then they are passed to the next stage of the development process. So the best example is a defect found at acceptance testing where the original mistake was in the requirements will require several products to be reworked. This is what we have seen yesterday, the very simple concept. If you have spotted a defect during a live or during the acceptance testing, which is the last phase of testing, you will not be able to fix it that easily. It might be due to a requirement defect. And you have to go all the way from your requirements, change your design, change your coding, and subsequently everything will have its own repercussion effects. So early testing we need to adopt. Next is defect clustering. It's a very simple concept. Defect clustering. All your defects are probably clustered or coupled tightly in one place. In the sense, what it is it depends on your system complexity. For example, let's say you are testing a banking application. Banking application in which the loan module you are testing. Loan module. In that loan module, we can assume that the 80% of the defects that occur in your module are due to the generation of your schedule, loan schedule. You have to generate the loan schedule. That might be having the problem because that is the important aspect or the critical aspect of a loan module in a function, right? So it depends on the system complexity, volatile code, the effects of change upon change, and then development staff experience and their inexperience. These are all the reasons for defects clustering. So, but what the principle states? Principle is nothing but a Pareto principle. Name of the principle is Pareto principle, in which what we state is that approximately 80% of the problems are found in about 20% of the module. Okay, the principle, Pareto principle, comes under defects clustering. Team, please understand, Pareto principle is covered under or comes under defect clustering. What it says is that 80% of your problems are found in about 20% of your modules. So your application might be very complex, but there might be only 20% of your modules which might be performing your mission critical functions. There you will find 80% of the defects. Okay. So this you can get it in a multiple choice. What Pareto principle states, they might give options like approximately 20% of the problems are found in 80% of the modules, something like that to confuse you. So please understand. So that's the reason why I highlighted in whatever the important points I am highlighting. Okay. So it is useful if the testing activity reflects this spread of defects. So what we need to do is that we target these areas and then we get the maximum defect out of it. High proportion defects can be found. But one more important thing that we need to remember, team, is that testing should not concentrate only on these parts. You should also focus on the remaining 80% of the modules. Here we are just covering 20% of the modules to get 80% defect. The rest 80% of the modules also should be covered. So that's what the principle states. Okay. Now, so far any questions, team? So it's all pretty straightforward and smooth. I think these topics are very easy to grasp and understand. So please post if you have got any questions. I'll be able to address it straight away. Alright. What is AUT? Yeah, good question. AUT is application under test. Team, we have got a question. What is AUT? I think somewhere in the previous session, see this one. Yeah, exhaustive testing. See here, application under test. Fine. Alright. So let's keep moving on. Next concept or next general principle is pesticide paradox. So what it says is that very simple. Yesterday also I have covered this concept. So if you run a test today, it has failed. Okay, you have run a test and it has failed today. Developers have, and you have raised a defect, developers have fixed it. Okay, and the next build, in the next build or next regression build they are giving, you are trying to take the same approach and you are trying to find the same defect. Usually it will not occur because, or you will try to adopt the same strategy on some other module, which will not happen. The reason is the developers will fix all those boundary cases moment you raise a defect. So whenever you are applying the same strategy or a same approach to crack, you will not be successful. Very simple. So what it says is that running the same tests continuously will not continue to find new defects. Okay, if you're running the same test continuously, if you don't have a different type of test, you will not find a new or a unique defect. Okay, so continuing with the same test set will result in decreasing the effectiveness of the test. But however, in the production, what we need to do, if you are having a problem, so if the problem has been reported and the developers have fixed it, still we need to do the regression to check whether we don't have that problem anymore. Very simple. If we are testing it in the production, so for example, if the code is given, so you have reported a defect and they have fixed it. Now the code has been delivered for the QA to test. Now you test it thoroughly and also you will do the regression. In regression, the test might be the same. There is no hard and fast rules. But what we are trying to say here, usually on a new piece of code, when you are trying to test and if you adopt a strategy, you will not be able to get the same defect over and again and again. That is the idea. That is called pesticide paradox. So you might get questions very simple and straightforward, like what pesticide paradox states. So it's a very simple and straightforward concept. So unless you know what it is, you will not be able to answer that question. Now, the most important thing is testing is context dependent. context dependent. It is not independent. We need to understand the technology used, architecture, the environment, and there are so many factors which will contribute to your testing strategy or the process. So different testing is necessary in different circumstances. So it is not a Bible that we follow like this is what we will do. We will start with smoke test, we will end with acceptance test, and we have to do security, nothing like that. You have to do performance, nothing like that. So unless it is required for the context, you will not do all these things. So testing is context dependent. And how we usually strategize based on the risk, probability of loss, and probability of failure. Okay, the best example would be your testing of e-commerce application versus online books website. So e-commerce websites such as you go for online shopping, you pay your credit card bills, or through credit card you do a purchase, or using credit card you pay a bill. So these websites are critical. Whereas there is an online book, you can go and read that book online. Just there is no username, no password, nothing. So it's an open context, open source. So where the security is more pronounced, so where we need to perform security testing, it depends on the context. Fine. The last is absence of error fallacy. So software with no known errors is not necessarily be shipped. So this is the punchline for absence of error fallacy. For example, if there is no defect, if you have tested it, if it's no defect, it doesn't mean that it is ready for shipping. Okay, so you have performed the test and there is no defect, it doesn't mean that it is ready for shipping. There might be n number of reasons that might be contributing to the factors that you have not got a defect. So factors, the fact that no defects are outstanding is not a good reason to ship the software. Very, very simple. Okay, fine. So before moving to the next topic, we will just do a quick recap. Give 3 reasons why defect clustering may exist. So we have seen the reasons: system complexity, code volatility, development staff experience and inexperience, and the effect of change upon change, in the sense your system keeps on changing. And then why is zero defects an insufficient guide to software quality? Because why? What is that? What is the reason? Because it doesn't mean that it's ready to be shipped, right? Zero defects doesn't mean that it is ready to be shipped. And what is the Pareto principle? 80% of your defects are coming from 20% of your modules. And what is the idea of early testing? Early testing will give you early defects, thereby you reduce your risk, error, and defect life cycle. This is the one. Okay, early life cycle, early testing. Great, team. Any questions so far? Probably I might be a little fast because these things are pretty easy. So if you have got any questions, I'm happy to answer. Great. So let's move on to the next topic for the day. Of course, the last, what is the main topic for the day? That is the process, fundamental test process. So this is what we have done. So we are done with why testing is required, what is testing, 7 principles of testing. Now we are in this context, fundamental test process. Okay, here we will not cover everything. We will try and cover till this implementation and execution. Okay, because this topic is pretty huge and we need to grasp many things. Some things you need to remember, means you need to remember all the context. Some things you need to apply your knowledge. We have talked about K1 and K2 yesterday, right? So all the type of questions comes from here. Great, team. So what is fundamental test process? So fundamental test process consists of 5 parts. That is, first is test planning and control. It starts with the planning activity and then you will control. Followed by analysis and design. Then you implement your process and do the execution. Actual role of testing comes here. Then you evaluate your exit criteria and do the reporting. Reporting, we know what we need to report, what we have executed, what we have found, what we have analyzed and all. And finally, it ends with the test closure activities. team, please remember this flow is very, very important. You might get a question based on this flow itself. So which one is the first fundamental test process? So they might give three options, among which you have to select the correct flow. It starts from planning and goes through analysis and design, then the implementation, and then evaluating the exit criteria, and then you will do the closure activities. Fine. Now let's talk about planning and control in detail. So it is a very, very important concept. Whatever we are going to talk right now for at least for next 15 minutes is going to be really important. Okay. So what is test planning and control? It itself says planning takes into account the feedback from monitoring and control activities which take place throughout the project. Please understand, planning happens throughout the project. This is a very, very important line. Do not miss it. They might ask you which phase you will do the planning. They might give you a few phases and they will also give you throughout the project. So ensure that you are following these lines. Control has the following major tasks. So first is determine the scope and risks and identify the objectives of testing. We have to determine the scope and risks and identify the objectives. Then we need to determine the approach. What approach? We need to talk about the technique, what are all the test items, coverage, identifying and interfacing with the teams, and also the testware, which like what is that going to be tested. Alright, first is the scope and risks, followed by test approach. Then we need to implement the test policy or the strategy. So we mentioned that there may be an organization or program policy and strategy for testing. So next comes the strategy. What we have to do then? We have to also determine the required resources. So what is there in the test planning? So everything we have to do, all these things we have to do as a part of test planning. People, environment, what are all the resources required, maybe the hardware, software, everything. You will take into account all the resources that are required for you to test. Then schedule, analysis and design tasks, implementation, execution and evaluation. You are doing a scheduling. You are not doing that how you are going to do. We are just doing a scheduling here. We are not executing it in the planning phase. Okay. And then determine the exit criteria. So we are just trying to determine the exit criteria. Alright. So these are the steps that we follow all the way from planning phase. So what are all the terminologies to be learned here? Very, very, very important thing. Please understand. Test plan document, what is a test policy, what is a test strategy document, and what is a test approach document. So we have got all these things to be understood as a part of this particular phase, testing phase, the test planning and controlling phase. Fine. Let's first talk about the test plan document. Any questions so far? Great. So test plan document, first it starts with scope. Okay. What it has the scope, it has the approach, and then you will also identify the test items, that is the features to be tested. Then you will also do a task, what you will do, in the sense who will do what. So I as a manager will do the planning, you will do the testing. So who will do what? Testing tasks. And degree of testers independence. So how independent we are going to test? Are we going to test in a separate environment, or are we going to test in a developer environment? It can be for any reason. So degree of tester independence, and then test environment, your design techniques. Also it has got entry and exit criteria to be used. And we also need to say why we are choosing that entry and exit criteria and the rationale for their choice. And we need to cover as well as any risk and how we can plan for it. It's the record for the planning process. So your test plan document describes all these things. So I have highlighted whichever is important, and these are all the things as part of planning that you do. Okay, team? And next comes the test policy document. What it contains is that describing the principles and major objectives of the organization regarding testing. Okay, it talks about the principle, approach, and major objectives. This is the important point. Major objectives of the organization regarding the testing. Then what is the strategy here? We have talked about plan, policy. Now it comes the strategy. It is nothing but the description of test levels. What are all the levels that you will perform as part of the testing process? High level description of test levels to be performed. Next comes the approach. So each document, probably we will not have it in our process. Maybe in your testing organization or the policy or the process that you have, we will not have all these things. We might just do the test plan document, or we will just do the test approach. That is why we talked about in a moment ago that testing is context dependent. What is required, you will do it accordingly. Fine. So approach, generally it talks about the test process, your test design techniques to be applied, and exit criteria and types to be performed. So these are all the things that we need to know. You might get a question that what a test approach document contains, what a test strategy document contains. So we need to know all these things. And then coverage, coverage is nothing but you execute a piece of code, in the sense you execute based on your tests, and we will see what is the percentage coverage of the code that is exercised by executing the test cases. Maybe a test script, manual, or even automated test script here. And then exit criteria. What an exit criteria is? Exit criteria set the generic and specific conditions. Let's say that what is the exit criteria for acceptance testing? Our testing team should have completed what are all the things? Should have completed the integration testing, system testing, and also the non-functional testing, so that it can be moved to the acceptance testing. This is just on a very high level I am talking about as a process. But what are all the criteria? You will set the criteria. There might be, you can set the criteria as 0, high, or critical defects that should exist when it has to be moved to acceptance testing. So you will design your entry and exit criteria. What is the entry point for each testing task, and what is the exit criteria? So it's a generic and a specific condition agreed upon with stakeholders. So there is again no hard and fast rules. This is what the industry standards are. No. You will agree upon with what the stakeholders based on their project criticality and complexity. Fine. Next is the control. So test planning we all know. Test plan we all have covered. So test control, in the sense it is the developing and applying a set of corrective actions. If something is going wrong, for example, if you don't follow the process, then this test control will come into the picture. No, we have to start doing this kind of things rather than creating some ambiguities within the system. So whenever there is a problem, the test management tasks, what they deal with it is apply the corrective action whenever it is going out of track. Alright. So what these test control tasks majorly has got? It has got measure and analyze the results of reviews and testing. So all these corrective actions are based on the result. You will you would have done this in the past, that didn't work out. So what corrective action you should take? So you will take that action. That comes under control activity, test control activity. You will monitor again the document progress, provide information on testing, initiate corrective actions, and make decisions. So which will enhance your quality of the product outcome. That is the reason why we are doing the control activity, test controlling activity. Alright. Now comes test monitor. What is a test monitoring means? You will monitor periodically what is happening. Simple. It's again a management task that deals with checking the status of your project. Are we going on right track in the sense how many critical, how many medium critical defects or low priority defects, something like this. Monitoring is a management task, deals with checking the status of the project. Great. This is the thing that we need to do. Testing, checking the status of the test project. What is test basis? So all documents from which the requirements of component or a system that can be inferred. So this is all about the documentation on which the test cases are based. This is what test base is all about. Documentation on which the test cases are based on. So very simple. So this is what we have got as part of test planning and control. We have first talked about what are all the things that we do, and then we talked about what a test plan contains based on the terminologies, what a test plan contains, scope, approach, and resourcing part. Apart from that, we also dealt with what is a policy document, strategy document, approach document, entry and exit criteria, and we also talked about, discussed test control activity. What is that means? And followed by test monitoring and test basis. Team, any questions so far? These are all the important things that definitely we should grasp so that you can answer your questions correctly. Because multiple choice questions usually confuses you with the options. Even if you don't have the options, you will be able to answer it correctly. Might be. But with the options, people get confused. Great. Let's get into analysis and design phase. This is again very simple. This is very simple when compared to planning and control. Okay. This describes what to test and how to combine our test conditions to test cases. What to test, what requirement, what is that we need to test, the test conditions, and we also do the combination of the test conditions. We will come up with the conditions. So how to combine the conditions. These are all the scenarios, or on a very high level. We will design our test conditions. So this particular line is very important. Analysis and design stage is the bridge between planning and execution phase. So analysis and design phase is the bridge between planning and execution phase. Now let's see what that design, test design. So what are all the things that we do as a part of analysis and design? So design involves predicting how the software under test has to behave. So first you need to understand how the software has to behave. So and then you will, that is nothing but you are predicting how it needs to behave. That is nothing but your test design will take into account. And then you will review the requirements, architecture, and you will comprise the test basis. From test basis, we have seen just now that your test cases are derived. And then you will also have the designing the test, including assigning priority, and then determining whether the requirements on the system are testable. Then we also have to talk about the test requirement, test environment should look like. We will also need to capture the test data required for conditions and cases, and traceability between the test basis and test case. So this is all what we do as a part of analysis. We need to analyze the requirement and come up with the conditions and cases. So the things that I have marked in bold and also highlighted are very important. Apart from that, on a very quick and high level, you should understand what we are doing here. We are determining the tests, assigning the priority. We also need to sort out our environment. We also need to do our highlight the test data, and we will analyze the test items to be tested. Great. What are all the terminologies here? What is a test condition? What is a test condition? An item or event or component or a system. It can be anything, any of these things. Could be verified by one or more test case. So it can be anything that should be tested by one or more test case is nothing but a test condition. So what is a test case? We all know this. Test case is heart of any tester, right? So any heart of the testing process lies in the test case. So the test case set of inputs that you will give, you will also have got expected and actual results. There is also a precondition and post condition. There is also the list of parameters to be tested. Everything is there. It's a part of test case. Test design and procedure specification. Design we have seen already how you will have the steps, in the sense documenting, specifying the test conditions and coverage that is going to take. And procedure is nothing but specifying the sequence of actions for executing a test. Procedure is a document specifying a sequence of actions for executing a test. Then comes the test data. Without test data we can't test. We have the test case and also we need to have the data for it to test. Various combinations you will have it. Maybe with the boundary conditions, with the parameterized values, with covering all permutations and combinations, you will prepare the test data. Okay, fine. So we have completed 2 subtopics so far. One is, as per, if we go test planning and control, test analysis and design. We have also talked about the important aspect, that is the terminologies, to understand what each terminology has got and what is the outcome of it, what we do, right from planning and then the design phase. Now last topic for today is implementation and execution. So this is the actual testing process where actually you are doing the testing. This is the stage where you are carrying out your testing by executing the piece of code written by the developers, right? So test implementation and execution involves running of tests. You are executing the test. It also includes necessary setup or tear down activities that are required for testing. So you will do the testing, you will perform the actual testing on the piece of code. And what you will do if the expected results are not equal to actual result, this means that not equal to. If expected results are not equal to actual result, you will raise the test incident or test defect report. Test defect will talk about it. It has its own the workflow, which we will discuss later. After you raise a defect, it is analyzed by the developers and then they will fix it. Okay. So when software or data changes, carry out retesting and regression testing respectively. Very, very important point, team. When there is any change to the software or when there is any change to the data that you are testing, you need to do a retesting and regression testing respectively. What is retesting? That's what we have discussed just a moment back. Still, I would like to reiterate. If you are given a piece of code to test, you have raised a defect in one of the areas. The developers fix it, it comes back to us. You again check it back to check whether the particular defect still existing or not. That is retesting. Exactly testing that scenario. Okay. A regression testing is by fixing that piece of code, have the developers broken somewhere else? In the sense, has it got any repercussion effects by fixing that defect? Is what you will check. You will check the relevant areas that are associated with that module. So retesting and regression testing, very, very important. You might even encounter the question very, very straightforward. What is the retesting and regression testing means? Okay, fine. So this execution phase, what and all we need to know is that we need to develop and prioritize our test cases. This is the phase that we need to develop and prioritize our test cases, write test procedure. It can be an automated test script or it can be a manual test script. Okay. Collecting test cases and where the test can be run. And then you will also check the environment setup, test cases order, that is priority or the way in which you want to execute, and keep a log of existing activities. What is that log means? Is it pass or fail? Is the expected is equal to actual? That is what we are talking about log here. And comparing your actual and with expected result and reporting the discrepancies means raising the defect is also associated with this phase. What is this phase? Test, implementation and execution. This is the phase that we are talking about. Okay. So very simple phase which we can correlate, because this is the exact phase which we would be doing actual testing. Fine. So what are all the terminologies that we need to know? The last 4 terminologies for today. So test suite. What is a test suite? Set of several test cases. Okay. Test suite in the sense, let's say if you are testing a very big application like let's say AmericanExpress.com. So we need to segregate each one to different modules. So each module will have a list of test cases. So that module, whatever you are developing based on the module, we will call it as a test suite document. Okay. And then execution, we know you will you will execute that line and then check whether your expected result are equal to the actual results. Great. And then test log, a chronological record for relevant details about the execution of the test. So log we have already discussed. What is the result of your test is what you will put it in the log. And incident, any event occurring that requires investigation, that is the defect. Any problem that you encounter during the execution, you will record it in the test incident report, which will be further taken for investigation. So we will stop here right now because it would be too much to complete everything in this topic. So what we have covered here is that planning and control is done, analysis and design is done. We have also done with the implementation and execution. Okay. So before we get into the mock test, team, please feel free to ask your questions if you have got any, and then we will kickstart our test for the day. So you will have 10 minutes to answer 10 questions. I know it's going to be little time bound. I know it's not the real testing scenario in the sense you have got 40 questions in 60 minutes to answer. Whereas now what I am trying to give you was just about 1 minute for each question. Still, you will be able to answer it, I believe. Because it's not a real-time simulation. Still, if you can perform here, you can definitely perform in your examination. That's the idea. Fine then, team. So let's get started with the test. So I will launch the test. You should be able to see the test on your screen. 10 minutes from now, I will just close the test and we will discuss the outcome of that questions. So what is the right answer, and then we will close it out for today. Alright? Great. So before I launch the test, just couple of things. Starting next session, that is day 3, is going to be only for the premium members. So if you feel that this is how it's going to work, and if you are ready for it, it's time to take ISTQB examination, please do join us. I'll give the rest of the details after the examination. So starting next session, it's going to be for premium members, and the good thing about joining as a premium member is you will have access to at least 10 mock tests. You will have access to at least 10 mock tests, and you will be able to take the test right from our portal, ITeLearn.com. There you can just log into your account and you can start taking the tests. And you will also have the access to videos as well as the live sessions if you have opted for live plus videos. So for fees and for all the other things, please go to the portal and also see our contact our sales ID. So here we have it. See, learn at. So if you have got any questions, learn@ITeLearn.com. You can mail them and ask if you have got any specific questions regarding your access, regarding your timelines and all those things. Okay. For pricing, you can go to pricing page and check it out. And you can go to pricing page and check it out. So starting next session, it's going to be for premium members. So let's start our testing for the day. So I'm just going to launch the test. Yeah. So it's 10 minutes from now, I will stop. So you can start answering team. So I'm just closing the testing. All right. Now we will do the review. I think you would have got your scores by now. We will do a quick review of today's questions. So most of them are from real-time ISTQB questions which had appeared in the past. So these are not created just like that. Okay. So debugging is checking that no intended consequences have occurred as a result of fix. So what is testing by checking whether the software performs correctly, checking that previously reported defect has been corrected. So which one of this is the correct answer? And what is that? Which option of the implementation and the execution area of the fundamental test process? So comparing actual and expected result. Implementation and execution, we have seen that, right? When you are executing it, you will do this only, comparing actual and expected result. You will not develop the test, you will not write a summary, instead you will execute it. And then the 5 fundamental test process. So what is the order? So this is the order: analysis and design, evaluating exit criteria and reporting, and test closure activities. So good that I have 79% have got it correct. I am very glad. And the next question, again, I think the session is making a lot of difference. So what is correct with respect to regression? So what is a regression testing? Checking that no additional problems found in the previously tested software. Great, again 79% have got it right. Fantastic team, it's a good work. And next question is, which of the statement is most true? Testing different testing is needed depending upon the context. Fantastic, 86%, amazing. And when is testing complete? I think none of you have got it correct. When there is enough information for sponsors to make an informed decision about the release. It's not based on time, it's not based on the budget, it is not based on the high priority defects. Okay? This I think definitely you should note it down. And next is the following statement related to activities. So they have given the set of activities, that is evaluating the testability of the requirements, repeating the testing tasks, designing of environment, developing and prioritizing test cases, verifying the test environment is set up correctly. So all these phases, what they have asked for is which phase is falling into which part of the cycle. You can see this one, 1 and 3 are part of analysis and design. 3, 4 and 5 are part of implementation and execution. So very straightforward. So 1 and 3, that is the evaluating testability, and then 3 stands for the designing of test environment setup. So you need to understand each one of those very thoroughly. You go back and see the video, you will be able to see what we have discussed, and definitely you will be able to easily answer this question. And 71% have got it correct. I am indeed very happy about the outcome. So I feel the session is making a lot of difference. And which of the statement, the next question, that is the 8th question, which of the statement below is the best assessment of how the test principles apply across the life cycle? So test principles affect activities throughout the life cycle. I have highlighted this purposefully, and the outcome is very good. 86% have got it correct. And test planning has which of the following major tasks? So first is the determining the scope and risk, identifying the objectives of testing, determining the test approach, and reviewing the test basis such as requirements, architecture, and also the 5th option is determining the exit criteria. So first option is correct, that is we have to ensure that test planning has got 1, that is the scope and risks, 2, determining the test approach, and 4, determining the exit criteria. Okay, 3 is false, reviewing the test basis is false. So which scenario the test basis falls under? It's a test design, so it's not analysis, and it's not in planning and control, it is in analysis and design. So next is the last question, evaluating testability of the requirements and system are part of which phase? its analysis and design phase. So only 50% have got it correct. So we need to ensure that you have the clear demarcation between the phases, each phases of the test. Okay. So only by that way we will be able to get our answers correct. So each phase has its own significance and you definitely need to get it correct. Fine then. So before I think okay, so the screen, I think it would be in your area also. So whatever I am discussing, share with that, and sorry, so this is what I should have done it. So you can see I will just hover the mouse over again. So sorry, I haven't shared my screen. So this is what we have done so far. So debugging, what is debugging and what is the right answer. So I'll just give a minute for you to go do a quick walkthrough before we do the closure comments. Join us. It's going to be the date and schedule is going to be rolled out pretty soon. You can check it out on our website. The most important thing is the US and the India fees is different for both exam as well as the course here. So you can just contact this particular ID, learn@ITeLearn.com, to know the pricing for India. For US it's different, for India it's different. Okay. And starting day 3 it's going to be for paid participants, and you will have access to a minimum of 10 full tests, like throughout the chapters, which is like we will follow the blueprint of ISTQB, and most of them would have appeared in the past. Okay, so this is all what we have. Any questions before we wrap up the session, team? I am glad to answer. So any other questions? So I have not got any questions. That's fantastic, team. So please go and brush through these concepts before we start day 3. I hope we will all meet once again starting day 3 onwards. Thanks a lot, everyone. Thanks a lot for joining. If you have got any other questions, please put it in the forum. We have got a tech support as well, which is 24 hours. If you have got any other questions if you want to discuss, especially ISTQB, there is a separate forum here created only for ISTQB. Please feel free to post all your questions. Thanks a lot. See you from starting day 3 onwards. Have a nice day, team.